Hi students, in this session let us learn what is E-plane T-junction and how to determine the S matrix or a scattering matrix of E-plane T-junction. Okay, so this is the geometric representation of E-plane T-junction. So here the E-plane T-junction having three ports, port 1, port 2 and port 3, where port 1 and port 2 are collinear arms and where port 3 is side arm, which is also called as a E arm. So here the side arm which is perpendicular to the collinear arms. So what is the major difference between E plane and H plane are there is two difference between E plane and H plane. What are the two differences? The first difference is here the H arm is parallel to collinear arms. Coming to E plane, the E arm is perpendicular to collinear arm. Okay, so the second difference is if input is applied to port 3, then the power is equally divided. Power is equally divided between port 1 and 2, port 1 and 2 and having in phase. Okay, so coming to the E plane, so here same input is applied to port 3 and power is equally divided between port 1 and 2, but the difference is here it is having a out phase or you can tell it as 180 degrees phase shift. Okay, so these are two major differences between H plane and E plane T junctions. Now we have to determine the S matrix for E plane T junction. So first step to determine the S matrix is first you have to determine the size of that matrix. So for that you have to know the number of ports. Number of ports of E plane T junction is 3. Therefore the size of the matrix is 3 by 3. Okay, now so you can write the 3 by 3 scattering matrix is S11, S12, S13. This is the first row. Coming to second row, S21, S22, S23. Coming to third row, S31, S32 and S33. Okay, so here there are 9 elements. To determine these 9 elements for S matrix of E plane T junction. So for that first we have to take some properties of the E plane. So the first property is, so here the input is applied to port 3. There is no reflections to port 3. No reflections in port 3. Why? Because the port 3 is perfectly matched. Port 3 is perfectly matched. So that you can take it as if input is applied to port 3, output is obtained from port 3 is no signal at port 3, no reflections, means you can take it as 0. S33 equals to 0. Now let's go to determine one more condition which is regarding to E-plane. So here, according to the definition, so whatever the input is you are applying, that is equally divided between port 1 and port 2, but having a phase shift 180 degrees. So this can be represented in terms of S parameters. So here input is applied to port 3 and output is obtained from port 1. Similarly, the input is applied to port 3, output is obtained from port 2. So according to the definition, the power magnitude is same but having a phase difference 180 degrees. This negative indicates the 180 degrees phase shift. Okay, so with this E-plane geometry, we get S33 equals to 0 and S13 equals to minus S23. So now we have to consider the properties of S matrix. What is the first property we have to consider? This is symmetry. Okay, according to the symmetry property, you can say that Sij equals to Sji. Okay, so here you can write it as S11 or S12 equals to S21, S13 equals to S31, S23 equals to S32. Okay, now we have to consider one more property of S matrix. It is unitary property. So according to the unitary property, you can say that product of S matrix with its complex conjugative which gives an identity matrix I. Okay, so now you have to rewrite the scattering matrix after considering the properties of E-plane and symmetric properties of S matrix. Okay, now we can rewrite it as S11, S12, S13, S12, S22 minus S13. Third row, S13 minus S13, 0. Okay, now you have to apply the unitary property, that is product of S matrix and its complex conjugative. So let us do it. S11, S12, S13, S12, S22 minus S13, S13 minus S13, 0. S11, S12, S13, S12 star, S22 star, this is complex conjugative, minus S13 star, next 13 star, minus S13 star and 0, which its product is equals to identity matrix, which is also size 3 by 3, 1 0 0 0 1 0 0 0 1. Now you have to do the matrix multiplication. Let us consider multiplication of row and column. Okay, first we have to consider the row 1 and column 1 product, which gives S11 S11 star, S1 plus S12 S12 star plus S13 S13 star. Okay, so which is equals to 1. So you can write it as modulus of S11 square plus modulus of S12 square plus modulus of S13 square equals to 1. Okay, so let us consider this is equation 1. Similarly, let's go with R2 and C2. R2, C2, similarly we get S12 modulus square plus S22 modulus square plus S13 modulus square equal to 1. So let us consider this is equation 2. And let's go with R3 and C3. So here it is S13 modulus square plus S13 modulus square equals to 1. Okay, let us consider this is equation 3. Now let us go with equation 3. So here we are having modulus square of S13 modulus square of S13. So you can write it as 2S1 modulus square equals to 1. That implies a modulus square of S13 equals to 1 by 2, which implies S13 equals to 1 by root 2. Okay. So from this we got S13. Already we know that S13 is equivalent to minus S23. Okay. That implies S23 equals to minus 1 by S2, 1 by root. Okay. So from this we got two values. Okay. Next, now compare equation 1 and 2. So by comparing equation 1 and 2, let us conclude some condition. Let us see. So here we having S12, and here also we having S12 square. Here we having S13 square. Here also we having S13 square. But in equation 1 we having S11 square, and in equation 2 we having S22 square. So by comparing the equation 1 and 2, you can conclude that modulus of S11 square equals to modulus of S22 square. So modulus of S11 square equals to modulus of S22 square. Okay, so you can write it as S11 equals to S22. Okay, this is one more conclusion. And now let us consider one more row and column multiplication. So that is S in S matrix R3 and C1. So let us consider the multiplication of R3 and C1, row 3 and column 1 in complex conjugative of S matrix. So row 3, this is the row 3, and this is the this is the row 3, and this is the column 1. Let us multiply S13 into S11 star minus S13 into S12 star, and 0 into this becomes 0, which is equivalent to 0. Okay, which is equivalent to 0. Which is equivalent to 0. So now let us write it as S13 into S11 star minus S13 into S12 star. Okay, you take it here, S13 is common, you take it as common. S11 star minus S12 star. Okay, so already we know that what is S13 equals to 1 by root 2. Okay, if any two factors is doing multiplication or we are doing product, so its product is equal to 0 means either any one of the factor becomes 0, or else both factors becomes 0. So but this is not possible. S13 should not equal to 0, so that from this we can conclude that S11 star minus S12 star equal to 0. That implies S11 star equals to minus S12 star. Okay, so it's S11, sorry, this is plus S11 equals to S12. Okay, so you can conclude that S11 equals to S12. Okay, already we get S11 equals to S22, and here S11 equals to S12. Okay, now let us consider equation 1. So what is equation 1? So this equation 1 is used to determine the S11 value. Let us see. So S11 equation 1 is S11 square plus S12 square plus S13 square. So let us see that S11 modulus of S11 square plus modulus of S12 square plus modulus of S13 square equal to 1. So we don't know what is S11, okay, and we know that S12 equals to S11, so you can write it as S11 square plus what is S13 equals to 1 by root 2. So you can write it as like this. So this is, you can write it as 2 into S11 modulus square plus 1 by 2 equals to 1. Okay, now what will happen? 2 modulus of S11 square equals to 1 minus 1 by 2, which gives 1 by 2, and modulus of S11 square equals to 1 by 4, and it means that S11 equals to 1 by 2. Okay, so with this all the 9 elements we are determined. So that now you have to write the matrix, S matrix with the corresponding values. Okay, the S matrix is, first one S11, S12. Okay, so in first row S11 equals to 1 by 2, S12 is also 1 by 2, and S13 is 1 by root 2. Okay, so second row 1 by 2, 1 by 2 minus 1 by root 2. Third row minus 1 by root 2 minus 1 by root 2 and 0. Okay, so let us consider the relationship between the output ports and input ports along with the scattering matrix S. Okay, so this is the relationship between the output ports. So B indicates the output ports, S indicates scattering matrix, A indicates the input ports. So here it is 3-port network, so you can write it as B1, B2 and B3. So 3 ports which indicates the output, and here this matrix 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus 1 by root 2, minus 1 by root 2, minus 1 by root 2 and 0. So, and input ports are A1, A2 and A3. So now by using this matrix, so you can write the corresponding equations for B1, B2 and B3. What is B1 here? A1 by 2 plus A2 by 2 plus A3 by root 2. Similarly, what is B2 here? A1 by 2 plus A2 by 2 minus A3 by root 2. And coming to B3, minus A1 by root 2 minus A2 by root 2, and 0 into A3 gives 0. Okay, so this is the output equations, output port equation B1, B2 and B3. Now we have to take the some conditions whether the definition of E-plane is satisfied or not for respective ports. So for the case 1, I am considering that I am applying input to port 1, port 3, okay, and no input to port 1 and 2, okay, port 1 and 2, so that you can write it as A1 equals to A2 equals to 0, and here I am applying input to port 3, so you can write it as A3 is not equals to 0. Now substitute these values in above equation B1, B2 and B3 and find the corresponding B1, B2 and B3. So what will happen? So A1 equals to A3 by root 2 and B2 equals to minus A3 by root 2 and B3 equals to 0. So from according to the definition of E-plane, here whatever the input is applied, it is equally divided between port 1 and port 2. The power is equally divided between port 1 and port 2 and having a phase shift 180 degrees. Now let us see whether it is satisfied or not. So let us go with it. So here the input is applied to port 3 and here the output is obtained from port 1 and port 2 and where the obtained power is having equal magnitude, that is A3 by root 2 and A3 by 2, and having a 180 degrees phase shift which indicates with negative, okay, negative sign. So it is satisfied with the E-plane T-junction definition. Okay, now let's go with the second case, the quite opposite case. So here now I am applying the input to port 1 and 2, which is equal input I am applying to port 1 and 2. It means A1 equals to A2 equals to A. There is no input to port 3. No input to port 3. It means A3 equal to 0. Now substitute these values and you have to determine B1, B2 and B3. Okay, what will happen? If A1, A2 equals to A and A3 equals to 0 means A1, A2 and this is 0 and this is A3 value, it becomes 0 and A by 2 and plus A by 2. So you are getting B1 equals to A by 2 plus A by 2. So A by 2 plus A by 2 which gives A, and B2 equals to again A by 2 plus A by 2 which gives again A, and here A by root 2 minus A by root 2. Okay, from this we can conclude that if you apply the same input to port 1 and port 2, then you are getting B1 and B2 is same power and B3 is equal to 0. There is no output signal from the port 3. Okay, so this is about the E-plane T-junction and how to determine the scattering matrix for E-plane. Okay, so if you like, please like, share and subscribe for more videos. Thank you.